Okay, so picking up from where we left off, talking about the mole. So in the laboratory, the mole could be equal to different things besides a number of particles. And one of the things that you might remember is that a mole is equal to the gram formula mass. And we did some of these problems actually when we were looking at the error propagation. So we did some of these practice problems where we had to convert from grams to moles or moles to grams. And so you already know that if you have the gram formula mass of something, it's equal to the mass of that substance in grams. So for calcium, to do that, I would look on the periodic table. I would see that calcium's mass was about 40.1. And so if I zoom in here, I have 40.1. And that would be in grams. And so 40.1 grams is 1 mole of calcium. Now I could do the same thing for something like calcium hydroxide. So now I have calcium, that's 40, plus I have 2 oxygens, which is 32, plus I have 2 hydrogens, that's 2, and that would give me a mass of 74 grams for every 1 mole. Now notice, over here in the first one, I actually rounded this to the tenths place, and over here I rounded this to whole numbers. And so it doesn't exactly matter what you round to. Personally, I always round to whole numbers unless I'm doing something like an empirical formula. The IB exam, you may want to be careful. You may want to round to, like the tenths place, the hundredths place. But at the same time, though, you're mostly interested in getting the correct answer. So if you round to the whole numbers place, that's fine. So we could do the same thing for calcium chloride. And so now we can find the atomic mass of this. And so again, we would have calcium is 40, plus we have the 2 chlorines. And now the chlorines, when I do these, it's 35.5, and then it's times 2. And notice, with the chlorines, I do 0.5. It's one of those weird ones. It's 35.545. It's right in between those 2 numbers. So I keep that, so that gives me 40 plus 71, so that is 111 grams per mole. So now, most of the time, we're just going to, write this as where we would have calcium chloride, for example. We would say that for that one, that could be 100, that could be 100 grams moles negative 1. And same thing, like we would say that this could be 100 grams per mole. The IB hates this. They want you to write this. And we can also do molar volume. Molar volume, 22.4 liters at STP. This is for gases only. And again, it's at STP. If you forgot what STP stands for, it stands for standard temperature and pressure. The values for that are 273 Kelvin, 1 atmosphere. When we do gas laws, we'll do other units of pressure and temperature. You might know that this is also 0 degrees Celsius. So if we have 1 mole of hydrogen gas, we are going to have, 1 mole of chlorine gas, we're going to have 22.4 liters of it.
Seth, is this yours?
If we're going to have 1 mole of hydrogen gas, then we're going to have 22.4 liters of it. And sorry, Miss Carrillo doesn't know that I'm recording this video, but it's okay. And so, do they weigh the same? Well, we can look at both of their volumes. Well, they both have 22.4 liters for hydrogen, or we could have chlorine, 22.4 liters. But we have different masses. We have, for hydrogen, 2 grams per mole, and for chlorine, 71 grams per mole. So they don't weigh the same. And they don't weigh the same because their gram formula masses are different. So different GFMs. Now something else that you'll see used interchangeably, and it's important for you to note this, is that GFM, gram formula mass, is sometimes called molar mass. And this is used interchangeably. Molar mass, gram formula mass, gram molecular mass, all those terms are used interchangeably. We'll get back into densities of gases. So, how do the densities of these two gases differ? We'll talk about that, but we'll do that more when we do gas laws. So now a mole is going to be equal to these different kinds of quantities. So if you have 71 grams of chlorine, you could be asked, how many liters is that? How many moles is that? So when I look at that, if I have 71 grams of chlorine, well, 1 mole of chlorine is 71 grams. I can convert it. And there are 22.4 liters for every 1 mole. So I can convert it again. And so this will give me 22.4 liters. What I'd like you to do is I'd like you to try something like this question number 2 here. So take a minute, pause the video, try question number 2. Let's see how you do. So let's see if we can find the moles of this. Let's see what you got. If I take 500 grams, well, I would times it by 1 mole over 44 grams. And that would give me the number of moles of CO2. And if I go ahead and I take a look, well, what are the number of moles of that? So I do 500 divided by 44, and I get 11.4 moles. If I want to change this to molecules, well, I can take that 11.4 moles, and I can times it by 1 mole for every 6.02 times 10 to the 23rd molecules. That won't work. We need to reverse it. Let's try it again. 6.02 times 10 to the 23rd molecules for every 1 mole. So now I times that by 6.02, and I get 6.84 times 10 to the 24th molecules. Finally, I could do it with liters. 11.4 moles times 22.4 liters for every 1 mole. And I do that, and I get 255 liters, and that would be at SDP. So go ahead and try mole problem 3. Tomorrow we'll talk about this in class, and we'll go through it. Thanks so much.